Hello, and today we are working on 2.5 solving compound inequalities. What is a compound inequality, you might ask? Well, I have news for you. It is two inequalities in one. You thought doing one inequality was fun. Well, compound inequalities are twice as much fun. And they can be either an and or an or. And we'll talk more about this here. There's two types, an and or an or. And for an and, what we have here is it must be both. Okay, just like if you'd say, I want you to take out the trash and feed the dog, you'd have to do both. You can't pick which one. So it's just like that. Example, here you go, x is greater than 4 and less than 10. So it's got to be greater than 4 and less than 10. And ands you can write in one inequality generally. You can put kind of the smallest number and the largest number and put your x in between them, which looks a lot like what the graph is, right? It's in between 4 and 10. So you can write the and inequalities as one compound inequality rather than two separate. The or inequality, so that can be either one. So like this, x is less than 2 or x is greater than or equal to 5. It can be a number down here, 1 or 0 or negative 12, or it could be a number up here like 5 or 19 or 36 and a half, anything like that up here. Okay? So those are our two main types. Let's do some problems. Example 1. So this, I can tell right away, it's an and inequality. So I'm already thinking it's going to be something like this where it's going to be shaded in the middle, right? That's what I'm thinking. We'll see, but that's kind of what I'm thinking. So these, I can do these two different ways. I can do them as two separate inequalities. Let's do that first. So I can do 2 is less than or equal to x minus 4 and x minus 4 is less than 9. So see that I took this inequality, okay, and then I took this inequality where I end up writing that middle one twice because he's involved both with the 2 and the 9. So first I'm going to work this one out. Let's see, I'm going to add 4 to both sides. This is just the same as any old inequality. And so your x is greater than or equal to 6. And then over here, I'm going to add 4 to both sides, and I end up with x is less than 13. And so from that, I say, okay, well, I've got 13 here, and I've got 6 there. And let's see, the 6 is or equal to. And then I'm going to say, let's see, it's less than 13, so it's this way from the 13. And it's greater than 6, so it's to the right of 6, and it's right in there. The other way of doing these, and this will work if your x's are all in one place. If your x's are in the middle and it's written as one inequality, you can also do it this way. In case you're like, you know what, I'm a person that likes to get things done. I don't have time for all of these shenanigans, writing two separate inequalities out. I got things to do. You can do this. So, you know, we've always said, oh, everything you do to one side, you have to do to the other side, right? Well, what if you have a three-sided inequality like this? Whoa, yeah, boy. So we're going to add 4, not just to one side, but to the other two sides, because you have like a three-sided equation here. 6 less than or equal to x less than 13. It's the same thing as you got over here, just done a little bit quicker and a little bit with a little bit more pizzazz. You know, I'll be honest with you. You gotta have a little swagger to do that sort of problem there. There you go. So it's not for everybody, you know. There you go. Well, let's move on to example 2. Now this one is an or, and we can't do the ors, you know, with the three-sided equation. That's okay. We can work them both out separately. Add 3, 2x is less than 12 divide by 2, x is less than 6. Okay, and then over here, come on, multiply by 2, x is greater than or equal to 18. So now I've got 6 here, 18 there, close circle on the 18, open on the 6. And I do want to make sure that everything's, it's an or, so I'm thinking probably out here and out here, but I do want to double check. Okay, so x is less than 6, so that means to the left of 6, that looks good, and x is greater than 18, so that means to the right of 18. Okay, so that's good there. Okay, example 2, all done. Moving on to example 3, and so this is an and written as two separate things, so I'm going to have to work this out individually here. Minus x, just get all the x's on one side and your numbers on the other side. Add 3, x is less than 4. Okay, got that side done with. Look over onto the right side. We've got divide by -4, divide by -4, and x is, what's that? We'd have to do what? And flip the who? That's right, we have to flip the sign. Very good, don't forget that. That's the one thing that we have to really be careful of with our inequalities, is anytime you have to multiply or divide by a negative, you must flip the sign. So, or equal to there, open there. Okay, so get your number line all set up. X is less than 4, so that means we're to the left of this 4. And x is greater than or equal to -7/4, so that means we're to the right of the -7/4, and we're right in between those two. All right. Example 4, two-parter here, because these are both super fun, and they wanted to be together, the super fun ones. So graph this. All we have to do is graph. It's all written out for us. Okay, so it's an and, right? And so we've got our 5 there, and our 1 there, and we're all good to go. Let's see. So it's probably going to be in between the two, right? So x is greater than 5, so it's to the right of 5, and less than or equal to 1, so it's to the left of 1, right? So it's going to be out here and out here. Boom, that this way, and boom, that way. All good? Hopefully you are shouting at the screen saying, no, don't do that. Don't put that incorrect math up there and make my eyes burn. Don't even shield your eyes from the screen. So this is an and statement, right? If it's an and statement, I can't have a number that's both of these things, that's both greater than or equal to 5 and less than 1. That is impossible. It can't be in two places at once. It'll tear the space-time continuum. You don't want that. So, what does this mean? What possible numbers can you think of are greater than or equal to 5 and less than 1? There are no numbers, are there? There are no numbers at all. The answer, my friends, is no solution. That's it. That's the answer. So you're already kind of skeptical of this example 5, aren't you? Yeah, so you should be. Let's think about it. We've got x is greater than 1 or x is less than 5. Okay, so let's see, greater than 1, so we're greater than 1 or less than 5. So is it in between there? No, it's not, is it? But what is it? You knew it's something weird, so it's not just your basic answer. So it's an or, right? So what number could be less than 5 or greater than 1? Can you think of a number that's not less than 5 or greater than 1? It's any number. Anything will fit into one of these two. Think of a really big number. 100, I don't know, 500, a billion, whatever. It's greater than 1. Think about a really small number. 1/3, -1 billion, whatever. they're both less than 5. Everything would be one of these two because x is less than 5 covers everything from 5 to the left, and x is greater than 1 takes everything from 1 and to the right. Okay, and so between those two, you cover every number there is. So the answer is all numbers. Or you could say all real numbers, and we use our fun little sign there. Not sure if we've talked about that yet, but there you go. That's it. Those are a couple special cases, and then other than that, you've got your and your or, and work each one out, graph them. It's a good chapter here. Okay, that's all I got. Have a good one. Talk to you later. Bye.